Welcome to the first day of Introduce Investor Days. My name is Carl Bokvist. I'm an industrial equity research analyst with ABG. And this morning I have the pleasure of introducing Steve Dawson from Sintercast. So I leave it over to you.
Okay, thank you, Carl. So good morning. The last time that we presented at this event was back in March, and I'm happy to be here this morning to provide an update on our progress. Let me start with a short reminder of what we are and what we do. So Sintercast is the industry leader for the production of compacted graphite iron. And compacted graphite iron is a new type of cast iron. It's particularly good when you have both a thermal load and a mechanical load. And so our main application is for engines because we have the pressure and the temperature from the combustion. Compacted graphite iron is stronger and stiffer than the normal cast iron or than aluminum. And this allows engine manufacturers to make the engines smaller and lighter and to load them more heavily to make them more fuel efficient. So less fuel consumption means less CO2 emissions. We don't actually make the engines. We provide a control technology to the foundries, and they produce the engines and supply them to the original equipment manufacturers, the car and truck companies. Over the years, we've developed so that we have 52 different licensees for our compacted graphite iron technology, and those are based in 13 different countries around the world. About half of those are in regular production. The other half are either development or research installations, or perhaps they're full production installations that have not yet received a series production order. It's nice that it's now 2019. The first CGI engine was produced 20 years ago in 1999. It wasn't just the first CGI engine, it was a Sintercast engine. And the market has really grown very well since then. So this year we'll produce well more than 1 million CGI cylinder blocks. For those of you who follow Sintercast, you know that we count in terms of engine equivalents. And we developed this term, this engine equivalent term. So Sintercast is paid on a weight basis, right? And our castings have a wide variety of different weights. So our lightest casting is 2.7 kilograms, and our heaviest casting is 9,000 kilograms. So there's no meaning for us to talk about the number of engines or the number of components. And we've defined this term engine equivalents so that every engine is said to weigh 50 kilograms. So perhaps for a car engine that weighs 50 kilograms, it counts as 1. If it's a truck engine that weighs 300 kilograms, it would count for 6. And if we make a small component like a turbocharger housing, maybe it's 5 kilograms, we would need 10 of them to provide one engine equivalent. So while we talk about growing from the first engine in 1999 to more than 1 million today, the real count in terms of engine equivalents is that we've gone from 0 to more than 3.5 million today. So that's how we grew up. We grew up with this compacted graphite iron process control technology. But in the last few years, we've developed 2 new technologies for tracking and traceability. We've used our expertise in the cast iron foundry industry and our ability for process control and precision measurement to develop 2 new tracking technologies. And these improve the process control in the foundry, but also the efficiency in the foundry and the productivity. Today I'm going to focus on the compacted graphite iron because that's still the biggest part of our business. So what we do, as I say, we're primarily an engine manufacturing supplier. Here on the left you see 2 different engine blocks. And these are used for passenger vehicles. And when we speak of passenger vehicles, we mean cars, SUVs, and trucks. And both of those engines are about 3-liter displacement. You can see that they're both V6 engines. So today we supply these to Jaguar and Land Rover, to Audi and Volkswagen, to Hyundai and Kia, to Ram and Jeep. And in the bottom picture here, you see the Ford F-150. So Ford is our biggest end user. We have supplied 9 different engines to Ford. It's very interesting. Both of the engines on the left side are engine options for the F-150. The F-150 is the highest selling vehicle in the world. Last year, it was the only vehicle in the world that made more than 1 million units. It has 6 engine options, and 2 of them are the ones that you see on this overhead, both from Sintercast. And they are the 2 smallest out of the 6 engines that are available. So it's because of the higher strength and stiffness of CGI that we're able to load them heavily and drive this larger vehicle. If you think back 5 years ago, the F-150 had V8 engine options, a 4.6-liter V8, a 5.4-liter V8, and a 6.2-liter V8. And today we're powering this vehicle with 2 3-liter engines made in Sintercast CGI. And if you really want to make this contribution to the environment, this is the place that you start, right? You start with the big vehicles that consume a lot of fuel, and you start with the vehicles that have a very high volume. It's really no meaning to make 50,000 battery vehicles. If you want to make a big contribution, you make a big reduction in the fuel consumption of a high volume vehicle. Our 2 engines have approximately half of the fuel consumption of the other engine options for the F-150. So that's on the passenger car side. We're just going to scale now. So this is, again, our 3-liter engine scaled down. And we also make the diesel engines for the Super Duty pickups in North America. And now these are 6 or 7-liter engines. We still classify these as passenger vehicles. So at Sintercast, we reason that if a vehicle is used to carry a person, and whether he uses it for pleasure or for business, it's still a passenger vehicle. And we only call commercial vehicles the bigger vehicles that carry boxes and freight. Yeah. Today, more than 80% of the Super Duty pickups in North America use a diesel engine, and that's Sintercast, both for Ford and for Ram. And today we're producing more than 1,500 per day of these Super Duty engines. So it's really a big part of our business. There's no meaning to use a gasoline engine in these vehicles. If you're up at 6-7 liters displacement in this heavy vehicle, the fuel consumption is just too high. You'd be stopping at the petrol station twice per week. So that's why the majority of them are diesel engines and will continue to be diesel engines. So let us scale up again. So now we have the 3-liter passenger vehicle engine, the 6 to 7-liter mid-range diesel engine for Super Duty, and we're also producing commercial vehicle engines. So on the commercial vehicle side, as the engines get bigger, the loading is heavier, so the firing pressure inside of the engine is much higher. So there's an even higher need for stronger materials and compacted graphite iron. Today, we produce both the cylinder block and the cylinder head. We do that for 22 different components. Our smallest commercial vehicle engine is 3.9 liters. So think of something like a dump truck or a utility truck. And our largest is 16.4 liters for a long-haul commercial vehicle. Yeah. And I think that this will be the highest growth opportunity for Sintercast in the future. This is really where we have the need for CGI. And I've said before, I don't know if it will be in 10 years or in 20 years, but in the fullness of time, all heavy-duty commercial vehicle engines will move toward compacted graphite iron. So we can scale up once more. We have our 3 and 6 liter engines, our commercial vehicle engines, which are maybe something like 12 to 15 liters. And we're also active in the industrial power sector. So this is now engines that we do, smaller engines for tractors, agriculture equipment, construction equipment, rail, and here you see an engine that will be used either for marine or for electricity generation, industrial power generation. On these engines, we do the piston rings, as you see in the top left picture. So they range from 250 to 980 millimeters in diameter. And we're also in development of the cylinder liners. So we hope that that production will start soon. We've been in development for some years now, and it's going very well, and that production will begin. So it's not all this size. As I say, the off-road equipment that we make for agriculture, we do a 7.8-liter engine for a tractor. We do 13-liter engine for harvesters. The engines that we do for rail applications are around 100 liters, and then you get these very large engines. So summarizing, for the passenger vehicle application, we're in production of engines that are around 0.5 or 1.0 liters per cylinder. Those 3-liter engines that I showed in the first picture, the petrol engine that we use for the F-150, we produce about 1,000 per day. And then again, as I mentioned, for the Super Duty pickups for Ford and for Ram, we're producing about 1,500 per day. So it's really high volume. On the commercial vehicle side, the engines range from about 1 liter per cylinder to 2 liters. So you think of a 6-cylinder engine, 12 liters, it's 2 liters per cylinder. And for the industrial power, up to 2,500 liters per cylinder. It's really fascinating. It's the same technology. It's an internal combustion engine. It's just scaled up. And we do all of these different sizes of components with the same process control technology. We just change the calibration of our equipment. So as I mentioned, about 1,000 per day on the passenger vehicle side. We speak of a pyramid in the industry. So you have this pyramid where at the bottom you have the smaller engines, which have a very high volume. And at the top of the pyramid, you have the very large engines, which have a low volume. So for the passenger cars, something like 1,000 per day. Commercial vehicles, if you made 50 to 100,000 per year, it would be a really good runner. And for these very large engines, those companies would be happy if they made 300 per year. Yeah. And then breaking it down into our market penetration, approximately 55% of our current production comes from passenger vehicles, about 40% from commercial vehicles, and 5% from industrial power. And that's reflecting this pyramid that I refer to. I think that longer term we'll maintain a balance something like this, but the commercial vehicles have the highest growth potential, and they will ultimately grow to be our biggest sector. How we do it? So if you were to look under a microscope, this is what compacted graphite iron would look like. It's not a technical meeting, so I don't want to go into that detail. But in terms of the properties of the material, it's about 75% stronger than the normal cast iron or aluminum. It's about 50% more stiff, so you need 50% more energy to bend it. And the most important parameter is what we call the fatigue strength. So if you remember when you were young, you would take a beverage can and you would bend it, yes? And it didn't break the first time you bent it. You had to bend it back and forth, and ultimately it would fail. And this is kind of the measure of fatigue strength. Nothing breaks the first time that we use it. Yeah? But if we use it over and over, there's a chance that it will fail. And as engineers, we have to design things to be sure that they won't ever fail. Doesn't matter if it's an airplane or a bridge or an elevator cable or an engine. Yeah? And the fatigue strength of compacted graphite iron is double of gray iron, the conventional iron, or aluminum. And that means that we can load it so much more heavily and still be sure that it will never fail. Yeah? And by loading it more heavily, we get more performance and better fuel economy. This is a photograph of the equipment that we supply. There'll be a video coming in the next slide. So we install this type of equipment. There's a display for the operator to interact with the equipment. There's 2 modules for him to take a sample. We analyze the iron after the foundry has melted it. The foundry buys raw materials, they melt them in a furnace and put them into a pot. And this pot or ladle will move through the foundry and eventually cast into individual molds. And as it goes from the melting area to the casting area, Sintercast reaches in and we take a sample. And depending on the result of that sample, we can fix the iron before they pour it. And this second machine here is the wire feeder. So if it needs more alloys, we can use this machine to add them to the iron before they start casting. And they know that everything they produce is good up front. So that's a one-time sale. You need one of those for each production line in the foundry. And we then supply the sampling consumable. And so in the first photo, you see the sampling cup. So you use one of these as a consumable for each pot of iron. And this is the temperature measuring device. So that sampling cup, it holds a sample of iron that's about the size of a golf ball. And we let that solidify over 3 minutes. And we measure the temperature as it solidifies. And by measuring the temperature, we can say if it is good or bad. Yeah, and this is the temperature measuring device, and that sits inside of the machine. You can use it 250 times. So breaking down the business model, we sell the equipment. It's a one-time sale up front. And we sell the consumables. It's either one per batch or reused 250 times. And finally, we have a production fee. So it's really a royalty. The industry hates that word, so we call it a production fee. It seems to work. This is a small video then of the system being used in a foundry. So you can see our sampling module. Put the sampling cup on. That temperature, the thermocouple, is inside of the machine. Green light means ready to go. The operator takes a spoon of iron from the ladle. He lifts it over the sampling cup, maybe for 2 seconds, and the sample is there. And now we wait for 3 minutes for the sample to solidify. Here he's just taking a chemistry sample. It's a different thing. So again, taking a spoon of iron from the ladle, lifting it over our sampling cup for a couple of seconds. Yellow light goes on. He can lower the spoon, and now it just sits there and solidifies. When it's solid, as say about 3 minutes, we'll decide how we have to change the iron before starting to cast. It's a really nice technology. It's an elegant technology. The foundry engineers can understand it and can embrace it. And they can also change it. It's not a black box. It's open for them to use it as they wish. So moving from what we do to what we've achieved, this is a plot of the development over the last 10 years of our series production in terms of engine equivalents. And you see that currently we finish at around 3.5 million. In September, we hit 3.9 million. It's a fun story. The last time we were here in March, just the day before, we issued a press release to say we'd broken the 3 million engine equivalent milestone. Yeah. And in September of this year, we had 3.9 million, our highest month ever. So the growth is continuing. In the forecast, 4 million is tangible. We see 5 million. In our industry, you see the order book really well for 3 years. There's a 3-year planning lead time in the automotive industry. As many of you know, we recently signed an agreement to install at the new foundry in Scania. It will ramp up between 2020 and 2025. So we have a better than normal visibility for the next 5 years. And we can see this growth continuing. Our revenue for the 3 quarters year to date was 87.2 million. That's up 38% on 2018. And it's interesting, after 3 quarters, we're more or less equal to the full year revenue of 2018. The operating result for the first 3 quarters is 36 million, and that's up 65%. So what it shows is that we can grow the revenue side without really growing the cost side of the company. Yeah, we've already established the base of the company to serve our customers. So we'll continue to grow on the revenue side, also on the expense side, but the revenue grows faster. If you look at these numbers, so you have 87. You do that math and you calculate it out, you annualize it to the full year. It means we could potentially be something like 115. It's not a forecast, it's just math. We have 23 people. It means that our revenue is 5 million Swedish crowns per employee. And if you do the same thing with the operating result, we're at 36, it's 12 per quarter. That means 48 for the year. Yeah. And again, we have those 23 people. We have a profit of 2 million Swedish crowns per employee. Yeah. So here I am, it's a 2-day event. I think you have about 40 speakers, Think back on Thursday night. How many people of those 40 have 2 million Swedish crowns of profit per employee? We've built a good thing. We've built a really good thing. The series production, as I said earlier, is now 3.5 million. We grew the series production 25% in 2018. And now, through the first 3 quarters of the year, it's actually 32%. So the growth is really strong. The sampling cups, we have consumed 141,900 of them in the first 9 months of the year. That's more or less on pace with the previous year. So we finish, last year we finished at 197,000. Again, do that math. Most foundries don't run on Sundays. Yeah, that's a maintenance day. Most of them have a summer or a winter shutdown. And so if you calculate, it means somebody is taking a Sintercast sample every 2 or 3 minutes somewhere in the world. So again, satisfies every definition of high volume production. And finally, from a compounded annual growth rate point of view, over the last 10 years, we've had an annual growth of 21%. CAGR is always difficult because it depends as much on where you start the calculation as where you finish it. So I've done it also for 5 years, and it's 14%. Whatever you do, it's clearly double digit. And for what we can see looking out over the next 3 to 5 years, we'll maintain that double digit compounded annual growth rate. So concluding, as a market outlook, we see growth in all 3 sectors. It means passenger vehicles, commercial vehicles, and industrial power. Our average installation revenue over the last 10 years was something like 7 million Swedish crowns. At the 3-quarter point, we already had 9.5. Our record is 10.1 in 2013. So you know that all of the 23 employees are fighting to get a record this year. We'll start to see a bigger contribution from tracking, both on the installation side and on the running revenue. We'll continue to have our double-digit compounded annual growth rate. And this running revenue, this is the basis of Sintercast. We've done a really wonderful job to establish the running revenue. To our knowledge, there are only 2 things in the cast iron foundry industry that have established a running revenue. One of them is the Sintercast production fee for compacted graphite iron, and the other is the Sintercast production fee for the tracking technologies. So really good future ahead. Thank you.
Perfect. Thank you very much. So I believe there is time for, well, hopefully at least 2 questions. I would like to start off, as you say, your current operating model is, by any way you look at it, very profitable. I'm just interested here, have you seen any pushback from the customers? Often in industries where there is a sort of over-profitability, you tend to see people either wanting to have a piece of the cake or your customers pushing back.
It's not easy to take money from people. Nobody likes to pay. So we had to enforce that from the very early years. We had to establish this business model. I would say to the contrary, our technology is valued, our technology is needed. Our technology, if you think about selling a casting, our total technology fee, the sampling consumables, the production fee, probably works out to around 2 or 2.5%. So every foundry knows that they can stop using our technology tomorrow. What will happen is their scrap rate will increase by more than 2 or 2.5%, and they'll have a net loss. Yeah? And that's why people continue to use it, and people continue to send us money at the end of the month. And to the contrary, there's always a pressure, but we get price increases on a regular basis. So we go back to the customers regularly, and the world changes. We need to increase our prices like everybody else. So pressure always, pushback no, price increases yes.
Yeah. And the final question here before we run out of time, looking into next year, 2020, I think there's a consensus that the commercial vehicle side, if we look at trucks in the US, is expected to decrease. And how do you expect to mitigate this? What do you see are the drivers behind why Sintercast should grow next year?
Yeah, I think you're right that commercial vehicles have been hanging on, so that may go down a little bit in North America. but we have new products coming on stream which offset that, right? So Sintercast is always about what you've got running today and what's new coming in. So if the economy goes down a little bit, the new stuff can more than compensate for it. So we're all about new products coming on stream. This year we've grown a lot, but much of the growth is because the Cummins 6.7 liter engine started at the beginning of the year, and it's running 400,000 engine equivalents. Yeah, so it's the new stuff. It's not just about the economy. And the second thing about next year, we've already announced the Scania installation, which comes in the middle of the year. We recently announced a new installation in Brazil at WHB, which has a purchase option in April. Last week we announced a new installation at FAW. All of those will be made next year. All of those will go to P&L next year. So, as I say, we've got an average installation revenue of something like 7 million per year. This year we are already at 9.5, hoping to break the record of 10.1. And I can't possibly see how next year can't be a record. You know, when you already have 3 big installations in the book, and there's always a few that pop up. So whatever we do on the running production side, installations are going to be bigger than normal. And yeah, how can it not be a record year?
Yeah, I think we have to end here. Thank you very much.
Thank you.